Okay, if you've just watched the video on expanding simple brackets, this will make a lot more sense. If you haven't recently watched the video on expanding single brackets, I would recommend watching it before you watch factorising, because factorising is the reverse of expanding the brackets. So, let's look at these 5 questions. When you do an exam question, it will ask you to fully factorise. And I want to be really crystal clear as we go through the examples what fully factorising means as opposed to partially factorising. So, partially factorising on here is spotting that these two things, 12x and 8, are both in, say, the 2 times tables. Partially factorising would say, oh, bring out the 2. And then I get 6x minus 4. That would not get you marks when it asks you to fully factorise. To fully factorise, the key thing you're looking for here is the highest common factor. Now, in terms of numbers, look, the highest common factor of 12 and 8 is 4. 4 is the largest factor. So it's the 4 that you pull out of the brackets. You then have the brackets left over. Now, you've got to look at this and think, 4 times what gives me 12x? Well, 4 times 3x gives me 12x. And 4 times what gives me minus 8? Well, 4 times minus 2 gives me minus 8. And my favourite thing about these sorts of questions is at the end, and I won't do this for all of them, but at the end you can actually expand the bracket, 12x minus 8, and have a little look and see if you've done it properly. Because if you have factorised it properly, when you expand it, it goes back to where you started. So it's a really nice sort of question to check your own answer, and it gives you confidence in the exam you've got the marks. So let's look at the next one. What's different here is that there's actually a y here and a y here. So when we're looking at factorising here, we need to think about what we could pull out. Now, because there's a y here and a y here, you could pull out the y. Just a single power of y would be factorising it. And you could say, okay, y times what gives me y to the power 3? Well, that could be y squared. And y times what gives me 3y squared? Well, that would be plus 3y. But it wouldn't be fully factorised. The reason it needs to be fully factorised is not just the number that you look for the highest common factor, but you also look for the highest power that appears in both. So the highest power that appears in both of these is actually y to the power 2. If you pull out as a factor y to the power 2, then when you look at your brackets, y to the power 2 times something gives me y to the power 3. That's just a single power of y. And to get it to say plus 3y squared, I need the plus 3 to multiply by the y squared. And that's fully factorised. In terms of numbers, you've pulled out the highest common factor. In terms of the letters, you've pulled out the highest common factor. Now put those two things together, and you won't come up with this question here. You could look at that, and you could see that the highest common factor is a 5 numerically. And you could just pull out the 5 and say it's that times 2a squared plus a. And you would have partially factorised it because you only looked for the number part, the 5. You also have to look at the letters, the algebraic parts here, and notice there's an a to the power 2 here and an a to the power 1 there. And the highest power they both have in common is a to the power 1. So to fully factorise it, we need to pull out not just the 5 as the numerical, but also pull out an a. This is fully factorising. 5a times something gives us the 10a squared. The 2 gives us the 10, the a turns it into an a squared. Plus 5a. Well, 5a times something is 5a. Hang on a minute. 5a times something is 5a. It's 1, isn't it? 1 lot of 5a is 5a. It's that plus 1 that very high achieving students still make mistakes on. It's a little thing that you've got to be careful of. Okay, let's take these ideas and apply them again. Numerically, the largest number that goes into 6 and 3 is 3. Algebraically, the largest power here, common power, is x to the power 1. So you pull out 3x. Now you know that you're fully factorising. This means you need a 2 times x here, 2x. And to make it say minus 3x, it already says 3x, something that we multiply by that turns it from 3x into minus 3x. Minus 1. Because minus 1 times 3x is minus 3x. Final question. Numerically, we've got a 2 and a 4, so we pull out the 2. Algebraically, we've got a p to the 2 and a p to the 1. The highest power they have in common is just the single power of p. You've got the bit on the outside of the brackets, and that's often worth 1 mark in the exam. So, let's see what it should be on the inside of the brackets. 2p times something gives 2p squared. We need a single power of p. And then 2p times something gives us minus 4p. Well, it needs to be negative to make it negative, and it needs to be a 2 to make it become a 4. And remember, at that point, if you want to check your answers, you very simply remultiply out your brackets. 2p times p, 2p squared. 2p times minus 2, minus 4p. And there you go. You can check yourself when you factorised by expanding the brackets and seeing if you get back to where you started from.